Is it sharing now?
Yes, it is.
Okay. So I was saying that one projectile is a motion of an object that is thrown or projected into air and then moves slowly under the influence of gravity. So a projectile, the key word there is an object which is only under the influence of gravity. So this is the key phrase, which is there whenever they refer to a projectile. Then for the second one, just for sake of revision, 9.2 is the hot air balloon in free fall. Give a reason for your answer. So the projectile, that is number 9.2. The hot air balloon is in free fall. You give the reason. No, the hot air balloon is not in free fall. Why? The reason: free fall occurs when gravity is the only force acting on the object. So the balloon is moving at a constant velocity, meaning other forces like the buoyancy and the air resistance, balance gravity. They are also acting on the what? On the air balloon. So it's not in free fall. Is it clear?
Yes.
Yes. So it was not in free fall. And then the last one, number 3, 9.3. 9.3, calculate the time it takes for the ball to hit the ground after it was dropped. So this one you can calculate, isn't it? The hot air
Yes.
balloon upwards at a constant speed of velocity. When it reaches a height of 22 meters from the ground, the ball is dropped from the balloon. So a drop, what is the initial velocity of a drop?
1.2 meters per second.
No, we are saying when it reached a height. When it reached a height of 22 meters from the ground, this hot air balloon, a ball was dropped from the balloon. So I'm saying, what was the initial velocity of the
1.2
balloon?
meters per second.
But the direction,
So
velocity, it must have direction. Is it upwards or downwards? Hello?
of the ball or the balloon?
Of the ball.
It
It's 1.2.
was
The second what?
1.2 meters per second
Downwards.
downwards.
Yes. Or you can say it's minus. So that when you're calculating, you know the direction is downward. Yes. Then the change in y. What is the change in y? When you're calculating the time, what will be the change in y?
22 meters.
Is it positive or negative? Is it
Negative 22 meters. Negative.
Is it positive or it's negative? When you're calculating the time for 1.3. So
Can you hear me?
VI. So there your VI. This is your initial velocity. U normally some
Negative.
yes. So it was going in the acceleration. Now, since it's down, acceleration it's 9.8 meters per second. Then the displacement 22 meters per second. Okay. So here they took which side? Downwards is what? Downwards is positive. Are you seeing? Downwards is
Yes.
positive. So VI is now positive, acceleration now positive. That distance, since I was going up, the distance was below, which means the distance is also now positive. Then you set up an equation, everything is positive. You come, everything is now positive. The distance is now in the same direction. So you arrange your things, quadratic formula, solving using quadratic equation, minus b plus or minus. Then you solve for t. So which means your t is either positive or negative. So negative plus or minus. So which means a time can never be minus time. So which means you have to choose the time that is going to be practically possible there. Okay. So which means we take the positive solution only. What do we mean by positive? Which means our two solutions, it's 9,1 negative 1,2 plus 20,8 over 9,8. So this is the one that we will take. If we take the one with the negative, it will give us a negative time. So we leave that one. So which means the time that we are going to take is this one, which is 2,0, approximately 2,0 seconds. Now let's go to the one that you wanted. The height of the balloon when the ball reaches maximum height after bounce, 6 Mach 10. So the height of the ball, the height of the balloon when the ball reaches maximum height. After bounce. So where was your challenge here? Where was your challenge? So that we start clarifying. The height of the balloon when the ball reaches the maximum height. Wow. Did you try to imagine the situation? Isn't it
yes, I did.
You must try to imagine what is happening. So which means the balloon is continuing to go up, isn't it?
Yes. The balloon is going down, so it's moving down. The balloon is moving vertically downwards.
With the what? The constant velocity of
1.2 meters per second.
With the constant velocity of 1.2 meters per second.
Yes.
Okay, so if the balloon is moving downwards with a constant velocity of 1.2 meters per second, it's moving downwards. So when it reaches a height of 22 meters from the ground, a ball is dropped from the balloon. Okay, so if a ball is dropped, so we are saying when the ball lands the ground, it is in contact with the ground for how many seconds? 0.3 seconds. Yes, 0.3 seconds. And then bounces vertically upwards with a speed of 15 meters per second. So the question is, calculate how high the balloon is from the ground when the ball reaches its maximum height after the bounce. So there are two things which are in motion, isn't it? So the balloon is continuously going down with that constant speed of 1.2 meters per second. And the ball was dropped and then it comes back and it was in contact for 0.3 seconds. So there are 6 marks. So let's check the approach. How you're supposed to attempt this one. All right. 9.4. So the time for the ball to reach the maximum height after the bounce. That is our starting point, which means the ball is at the ground after the bounce. So we are now at the ground. We are on the ground, which means the ball has already reached the ground. So we want to calculate the time from the ground, which means your reference point is the ground, which is 0, to the maximum height. And what do you know about this maximum height? What is the velocity at the maximum height? What is the velocity? VF.
So
At
the
that
network is acting up.
or the network is acting up. For how many
Yes.
minutes? You couldn't hear me for how many minutes?
Like I can hear you for some few minutes, then the next few minutes I cannot hear you.
Okay. So I'm saying our first step, we need to calculate from the moment the ball is coming from the ground. So we said from the ground, the VI is what? It says it came from the ground with the speed of how much?
15 meters per second.
meters per second.
Mm.
So we are starting from before we start from the issue of it, just when the ball is leaving the ground. Okay. So they asked how high. So the ball was in contact with the ground for 0.3 seconds. And let's calculate this height h, like from here to for the first bounce. What will be this height h? That's maximum height. So this maximum height,
Mm.
so we know about the final velocity. Final velocity, our final velocity VF is what? VF
0.
0. VF is 0 for the final velocity. So VF is 0. And what do you know about VF? VF is equals to V what? VI plus AT. Is that correct? Do you agree with this formula?
Are we looking for the time?
There are two ways of solving it, which means you can look for the time, then you substitute into the height by substituting that equation. Or you can use the VF. You choose what you want. But you can, the correct formula, which was very fast, is the VF1, isn't it? Isn't it? VF squared is equals to VI squared plus 2A change in Y.
Then I'm not sure if it's my network or yours.
You can't hear me.
Yeah,
You hardly hear
I'm
me.
not sure if it's mine. Yeah.
Yeah, but let's just try to manage. Sometimes here it's raining, so the network will be poor. Network will be poor, but I will go slowly. I am saying you can solve it, then you can find T, but the fastest way was for us to, if we want the change in Y, we have VF, we have VI, we can simply use this formula. Is that correct? Hello, Ulan, are you still there? Okay.
Yes, I'm there.
Yeah, so you must respond so that I still know that you are there. So change in 0 is the final velocity. Initial velocity is what?
15 meters per second squared.
15 meters per second squared. Then plus 2. Remember, it's a positive 2, but because the upwards is positive, then the acceleration It's negative what? A is equals to negative 9,8. So the 9,8 negative, which means positive times negative, it gives you this negative. Is it clear now?
Yes.
So positive 2 times 9,8. And then what is the change in y? So which means simplifying everything, it will give us 15 squared, 225. This is our change in y, which is just s, another unit for representing change in y, the displacement. So that s is just the change in y. So which means in our case, the change in y is 225 over 19,6, which is the change in y. In our case, the change in y. This is the change in y, which we are referring to. So from the ground to reach the maximum height, that height, the change in y was 11.4 meters. 11.4 meters. Okay, but we have not yet answered the question. So the maximum height of the ball is 11.8 meters. Then, now we want the total time since the ball was dropped. So which means the time since the ball was dropped, so the time to the ground from the moment the ball was dropped to the ground. We calculated this one, isn't it? Where we set up everything and we solve for t. Remember?
Yes.
That one we calculated on the previous question when I was explaining. So from the moment it was dropped, this time it was 2 seconds to reach. So while the ball has been dropped, also the balloon is moving. So that 2 seconds from that moment where the balloon is, we are calculating, the balloon is still moving downwards. So 2 seconds has elapsed. Now the ball reaches the ground. We are here on the ground. And the contact with the ground, it's 0.3 seconds. So which means that now the total time is 2.3 seconds. Then the time taken to the maximum height, that was the time taken to reach the maximum height. That's why you were asking here when we're dealing with time, like which time are you talking about? So this was, we were calculating the time to reach the maximum height. How many minutes, how many seconds did it take from the ground to the maximum height? So final velocity, vi plus at. So if I have a v initial of 0, final velocity of 0, and my initial velocity is 15, and I'm experiencing an acceleration due to gravity of -9, which means I will reach the maximum height at when 1,53 has elapsed. Any question then?
No.
Why we calculated the time first? The time was to calculate the time from the ground to the maximum height. And then the second formula which we used, we were calculating the height from the ground to the maximum height. So which means ground to the maximum height, we use the second formula. But we know that from the point of release when it was dropped to the ground, it's 2 seconds. And also contact time, 3 seconds. Time to move from the ground, now the ball is in contact, 2 seconds, 0.3, now it moves from the ground, coming back to the maximum height. So it took 1.53 seconds to reach the maximum height. And during this time, the balloon is still moving downwards. So the balloon is not stationary, still moving downwards with that constant speed. So how many seconds has elapsed? 2 seconds plus 0.3 seconds plus 1.53 seconds. So the total time that has elapsed while the balloon is moving downwards is 3.83 seconds. If you add 2,0 plus 0,3 plus 1,53, you get 3,83. So that is the step number 3, which we did, which we added the total time that has elapsed. Now the distance balloon moved down. What information are we having? We are having the balloon speed, which is the V initial, which is that constant velocity, which is the V initial velocity, which is the same at any given point in time, the initial velocity and the final velocity of the balloon is the same since it's moving with the constant velocity. Acceleration is 0. But we know that distance if you are using the distance formula to say distance is equals to speed times time. So this is the formula which we are talking about. Distance is equals to speed times time. So what is this speed? The V is representing the speed. So this S is just a distance. So distance is equals to speed times time, which is the speed times time. V is representing the velocity, which is the speed. So speed times time, our velocity times time, using that formula. Distance equals to speed times time. So we want the distance because we know the speed at which this balloon is moving. So the distance which needs to be covered, we don't know this distance. But what we know, the speed at which this balloon is moving from that point where it started, and we know the time it took. So we want to know the distance which it traveled throughout while this ball was dropped. It was dropped and then it had contact with the ground. Then from ground, it reached the maximum height. And from that point, the balloon was in motion for 3,83 seconds. And for 3,83 seconds, the balloon was in motion. We don't know where the balloon is when the ball has reached the maximum height, but we know it's after 3,83 seconds. And it's moving with a speed of 1,2 meters per second downwards. So the distance which it traveled, we use that distance formula. Distance equals to speed times time. So using the distance formula, speed times time, we found out the balloon has moved downwards from the point when the ball was dropped. The balloon had traveled 4,60 meters, approximately 4,60 meters. Any questions so far where you'd want so that we move? Okay. So if you are following, let's move on. All right, if you are following, so that is the distance, 4,60 approximately meters. Then the balloon height above ground, if it had traveled 4,60 meters. So the initial height of the balloon was at 22 meters. So which means if I'm here at the ground and the maximum height where the balloon is initial before it starts to drop the ball is 22 meters. And while the ball has been dropped and it went to the maximum height, which means the balloon has traveled a certain distance of 4,60 meters downwards, but it has not yet reached downward. So which means they are calculating, you want to calculate the balloon height above ground. So which means from here to there, which means now I must subtract 22 minus 4,60, which I get this 17,4 meters. Any question then? Of calculating the height above ground of the balloon. First, we have calculated the speed of the balloon. You calculate the distance by knowing, since we know the speed, we can calculate the distance by saying speed, distance is equals to speed times time. So the distance which the balloon had moved while the ball went down, reacted, or he was in contact with the ground, and then from the ground it reached the maximum height. It took 3,83 seconds. So that time we multiplied by the speed, we got the distance which the balloon moved during that time. It was 4,60. So if you want that distance above the ground, you subtract. So the balloon height, it was 17.4 meters above the ground. I don't know if the explanation is clear and you can follow.
Yes, it's okay.
Where were you stuck before? Where was your challenge?
I just couldn't make out the question.
But is it better now?
Yes.
It's better. Okay. So those are the steps which you should just follow, which we just discussed. Okay. Then the graphs, how did you manage to recap on the graphs?
I think I'm doing good with the graphs.
You don't have problem.
Yes.
So was this the only one which you gave you tough time? And this is the only one which gave you. Okay. And, yesterday we were talking of this projectile, and then let's see if we can have one of the graphs. We discussed the graphs there. All right, suppose the ball takes 3 seconds to reach the maximum height, A to B, then it will take 3 seconds to fall back, B to A. So which means here when they draw the acceleration, they drew it in such a way that the acceleration during those points is just a constant negative number, which means it's acceleration versus a time. So the acceleration is always constant if there is no any other forces acting on the object when you are drawing that acceleration versus time graph. Then let's analyze this one. So draw a velocity time graph for the upward motion A to B. Meaning, how do you interpret this one? The 20 is the initial velocity of the ball. So that one is 20 meters per second upwards. So when the ball is moving 20 meters per second upwards, which means if you have your initial velocity here, then you move 20 meters per second upwards, then the ball starts to come down. So at this point is where you have projected the object upwards. But is the velocity increasing as you are going up or is decreasing? Because initially and the final velocity there, it is now 0. Final velocity is now 0 at that maximum point. So which means after 3 seconds, after 3 seconds, the ball reached the maximum height. So that one is the maximum height. Is it clear?
Yes.
And if it's going to return to its point of release here, if it's going to return back to where it started from, how are you going to continue this graph? You just move again up to -20. which means this graph, we continue it up to negative 20. So at that point, assuming it's negative 20, which means it's back to where it started from. Then if it hits the ground at a certain velocity, and you know it's a negative, suppose it's negative 30 meters per second, which means you continue again until you reach that speed which it hit the ground, etc. So at this point here, it's where it started from. It's the original rest point where it was, like a parabola. Then it continues down. So this one is the velocity. And don't forget to indicate velocity in meters per second, time in seconds. If you have taken upward as positive, which means its velocity is decreasing bit by bit, but it's a straight line. So graphs are easy. Constant acceleration, just a straight line. Okay, so this one, dropping, and it reached the same point where it started from. When it returns to the same position, for example, like this, it starts with a positive 20, it returns back with a negative 20. So this will be positive 20 meters per second. This one to be negative 20 meters per second in the negative direction. When it reaches the maximum height, the velocity there is 0. So it's there at that point when velocity is 0. All right, so what does the area under the velocity versus time graph tell us? So that shaded area, which is above the axis, represents the upward positive displacement of the ball. So sometimes they might not tell you the distance traveled, they can give you a graph. So if you are able to calculate that area under that graph, that is the displacement going upwards. And this one will be the displacement going downwards. So going to and from, you can calculate that distance with the area under the graph. Why do we mean area under the graph? Because that area under the graph is representing the distance, which means you are saying your speed and you are having a time. So which means that velocity over time, t. Velocity, it's meters per second, which is your axis, and then times time, which is the s. So when the units are going to cancel s and s, then you're left with meters. So displacement in terms of the area under the graph. So the trick there, sometimes they might not tell you the distance traveled, which means there might be information that is missing. Then they give you the graph of what is happening. So from there, you should be able to pick up some things that to say, starting from initial, the velocity, you read it from where you have started there on top. And then the end point, you read the velocity when the ball returned. If you want to know the distance of going up and coming down, that distance, when the projectile was, the total distance moved by the projectile, you use the area is shaded. The area that was shaded. So there's a 20, half base times height. Area is given as what? Half base times?
Height.
Yes. So it's half 3 times 20, which is 30. Half 3 times 20. So half of 20 is 10. Times 3, 10. You do the same from here, from this point. Starting from 3 to 6, the distance here is 3. So half base times height. But the distance in the negative direction, yes.
If I just calculate the distance from A to B, then I multiply by 2, am I going to be awarded marks for it?
The distance from what? This is
From A to B, and then I multiply it by
A
2.
is this point. A is this point, the original point. B is the maximum point. Remember, B is the maximum height. B
Yes.
represents the maximum height. B represents the maximum height, which is reached by the ball there. Then A, it comes A, this is A, and also this is A. This is B, which is on top. So what is your question?
I was asking if, since you're saying that we should look at the area under the graph when we calculating for the displacement.
Yes.
If I calculated the displacement from A to B, and then multiplied it by 2, so I could get my distance from A to A, would they award me marks?
How are you calculating the distance from using Pythagoras? How do you calculate the distance from A to B? If you don't use Pythagoras theory. Because the only way you calculate the distance from A to B is using that Pythagoras theory. I don't understand if you are representing
I'm saying
A.
that if I use the area is equals to 1/2 base times the height, and then I multiplied my answer by 2, so I could get the total distance that
Ah,
was covered by the ball.
yes, it's correct. It's correct. It's correct. It's correct. I thought maybe you are talking to calculate the length of the slope. Then you say that is your distance. Then I was saying, no, it's wrong, that one. You can't use this slope to say this is my distance. It has to be the area of that triangle, like what you said, half base times height. And then, but since there are two triangles, they form a rectangle, isn't it? So instead of half base times height times 2, you can just say base times height, the total distance of going to and from. Because mathematically, we know area of a triangle is half base times the perpendicular height. So since these are two triangles, a rectangle is made up of two triangles. So first we have another triangle which is upwards, which is having the same length with the triangle which is at the bottom. So if this is my base, this is my height. And also that side, this is my base. On the other triangle, this is my height. So since there are two triangles, which means times 2, the 2 and the 2, they cancel. So you'll be left with the total area is just the area of a rectangle, which is base times height. Then you still get the same answer. Any question?
No, sir.
So here they've indicated the calculations to say the change in x is the area under the velocity time graph. So the area is half base times height, which is half 3 times 20, which means you get 30 meters. Then the displacement of the ball back to A, which means another distance, is 30 meters again. So adding the total distance when the object was in motion, it's 60. Going to and from, coming to the same position. So those are graphs. Some information, it comes from graph. So how do you know this line is positive gradient? Because it's sloping upwards. Negative gradient, the line is decreasing. Okay. Let's go to the graphs. This one now is a graph of what? Which graph are we? Position versus time graph. Yes. The position versus time graph. This is the one where you'll be drawing the parabola itself. So at the initial velocity is 0 on the final, on the maximum height. The velocity is 0. So this is the position time graph where you are sketching that parabola. So we have the velocity, the position time graph. and there's a velocity time graph. Then there's an acceleration time graph, whether they want to know the acceleration was positive or it was constant, negative. So this is our position time graph. It shows us the position, which is a parabola. From A to B, then it comes back to B. The ball returned to its reference point. So the reference point is A, it returns back. On these ones, they should be easy, not difficult. All right. So with this one, why it's dashed like this? So we are given a situation. A ball is dropped and bounces. A ball is dropped and bounces. Consider a ball which is dropped from a high cliff, point A, hits the ground, point B, and bounces back upwards and reaches the maximum height C. So there's a bounce there. So they want us to, let's draw the acceleration versus time graph, and also the ball is in free fall for the entire motion, except when it hits the ground. The acceleration of the ball always negative if it's in free fall, which means it's under the influence of gravity. So acceleration, if it's always negative, which means it's below the axis, which is 0. But when it hits the ground, it accelerates with a certain speed. So those dashed ones, they are telling you it's a bounce. Whenever you see that one, it's a bounce, those dotted ones. The moment it hits the floor, because the acceleration immediately went up. From there, acceleration was negative, going downwards. The moment it hits the ground, it shoots up, which means it goes up. It was a bounce. The ball bounced. Constant, which means negative acceleration. Now, after the bounce, it's going down. It's in free fall again. So that's how it goes in terms of some bounce. But in terms of the velocity, if you are having acceleration versus time, velocities of the ball are negative and increasing as speeds up. So this one, it's a negative acceleration. Then here we are also talking of the bounces. So whenever you see this diagram, you know that there was a bounce. So the ball was in contact with the ground here. The ball was in contact with the ground. So it tells you for how many seconds the ball was in contact. So that value, it tells you which position on a time graph, on a velocity time graph for a bounce, for a ball that bounce. So which means this position indicating you how many seconds was the ball in contact with the ground. Okay. Then
0.1 seconds.
0.1 seconds. Excellent. The ball was in contact for 0.1 seconds. How do you measure that one? Yes. It was for 0.1 seconds. That's correct. That's correct. So which means, how are you seeing? Which means from the moment it hit the ground, then the time it took for it to, the velocity when it left the ground. So you can see that the time is not the same when it hit and when it left the ground. There is a time frame where it was in contact, which was 0.1 seconds, which means we are correct. So these are the graphs which I was saying you should be able to interpret when you're in an exam. They ask those information. How many seconds was the ball in contact with the ground? Okay. Then the position versus time graph. And that is the position. Velocities are increasing. Therefore, the gradient must also what? Increase. So if the velocity increasing, the gradient of the slope must be increasing. So the velocity, the position time graph, you are sketching like a parabola. That is the trick. And then for the velocity, it's a slope. For acceleration, normally it's a constant line. It's a constant line. So let's analyze this position time graph. So here the velocities are positive, which means upwards. Therefore, the gradient must be positive. Velocities are decreasing. Therefore, the gradient is also decreasing on that R. Velocities are the ball has reached its maximum height after the bounce. So, which means you drop the ball, it reaches the ground, then the ball was in contact with the ground. That's why it's like this. It was in contact with the ground for some time. Yeah, it was in contact with the ground for some time. But when the ball left the ground, it reached this maximum height. This was the maximum height reached after the first bounce. So you check how many bounces did the ball have until if you see the line, it stops on the ground, which means the ball rested. It did not bounce again. So you check how many bounces until that curve, it rests on the horizontal line. Then you know the ball is now at rest. It can't bounce again. The energy has been exhausted. Okay, those are the graphs. And then this one is a graph showing a constant acceleration, which means here we are choosing upwards as positive. If upwards is positive, which means your acceleration is a constant acceleration of negative 9.8 meters per second squared. Can you see it?
Yes.
Yes. So that's how you know it. Upwards is positive. You draw a straight line, which is below the axis. Then this one is the projectile where we started with an initial velocity of upwards is positive. And then the point where you are starting, the position, it's not on the ground. You are not throwing on the ground. That is how this position time graph, it tells you that you are not projecting this ball on the ground. You are at a height, at a certain height above the ground. You are at a building. So this is the graph. You are at a certain height. The ball reaches the maximum point. Now it reaches the reference point. From reference point, it continues down. So this is the diagram for position. So master the position, you master the velocity time and the acceleration one. You'll be done. And you know also the bounces. So the bounces of the ball. Those are the curves. Like if you see these ones, you know there's a bounce here. And for how many seconds was the ball in contact?
0.2 seconds.
0.2 seconds. And how many times did the ball bounce?
Once.
Once. Those are the questions. Those are the questions. Interpreting the graphs. And this one is a what? It's a position
time graph.
It's a position time graph where it's telling you upwards is what? Is upwards. Now we are taking upwards as negative. So it's a more like you're just, it's a reflection or you're inverting the graph. If it was upwards as positive, which means the ball is starting here. If upwards is positive, it will be starting like this. Which means it reaches from zero. This ball is starting from the reference point, which is at origin, goes up, comes back to the origin, then it bounces, it is in contact, then it goes to a certain height, which is E. So this one is when I'm taking upwards as what? As positive.
Negative. Oh, positive.
Upwards is positive. You'll be taking upwards as what? As positive. But
Positive.
the moment, yes, the moment you take upward as negative, then it become reflected. It should be the other way around. Take upwards as negative. This one showing the bounce. How many bounces? Only once. There's one bounce. Contact with the ground. The contact time
0.005
0.05
seconds.
0.05 seconds. 0.05. Gradient, the slope. So position time graph. Where did you start? I started at 0, which means if it's going downwards, the position, which means which direction are you taking? Is it upwards or downwards is positive? Yes.
Upwards is negative. Upwards is positive. Sorry.
You are taking upwards as positive, but this is a position time graph. If you say upwards is positive, upwards is negative. It's upwards is negative, because how come you are going to throw a ball? Is your reference point even tell you where you are? Okay, you are starting at a reference point of 0. Then how come the ball is going to go below where you are? So which means upwards is what?
Upwards is negative.
Is negative. Yes, makes sense. So this one is the acceleration time graph. The bounce, when it leaves the ground after the bounce, this is an acceleration time graph of a ball that bounces, which means when it leaves the bounce, it does not move with the bounce with a -9. The acceleration, it accelerates because it's not under the force of gravity. It's not in free fall. Then after some time, it comes back to free fall. Okay. So these are the ones we should know. The bounce, we are done with that one. Then the organic chemistry is what we did that other day. Okay.
Yes.
So it's a matter of just you warming up question after question, trying. Now you know what to do in terms of organic chemistry. So we'll be just doing questions, projectile questions. I don't know from Monday which topic are we starting with.
We can start with the rate of reactions.
Yes, so rate of reactions on Monday next week. Okay. So we can stop here for now. Né?
Yes.
Okay. We'll see you on Monday. See you on Monday. Just keep practicing more problems. Where you are stuck, you can send. I respond like what I did. Okay.